What are you teaching today, Mr. Gray?
We are going statistics and area. Okay, so let us talk about statistics. So for the KC, there are statistics and probability questions. There are about 12 of them. So I'm going to go over the main. Thank you. I'm going to go over the main ones first, just kind of give you an idea. So the key three for statistics are these: mean, median, and mode. Okay, so the mean is just the average. Okay. Okay. The median is the middle, and the mode is the most frequent, or the one that's repeated the most. Okay, so if you have a set of numbers, they may ask you for the mean, the median, and the mode. So let's look at a question. This question says Chicago Bulls, but since we're in Los Angeles, we're not going to use Chicago Bulls. So we're going to say the Lakers scored 98, 110, and let's see, 112, and 120 points in a game. Here's hoping. All right, what is the mean score? So, and the mean is the average. To find the mean or the average, we add all of the numbers, and we divide by how many numbers we have. So we add these four, and then we divide by 4. Okay. So in this instance, with another color, we have 8, 0 is 8, plus 2 is 10. Carry your 1, 1 and 9 is 10, plus 1 is 11. Another one is 12. That's 14. Okay. And then we carry your 1, 1, 2, 3, 4. 440. Okay. And then we divide that 440 by 1, 2, 3, 4 of them. And that goes into there. 0. We bring down the 4. Goes in there once. 0. We bring down the 0. That goes in there 0 times. And so we end up with 110. Is that correct? Or is it right? Yes, please. Doesn't look right. Okay, so that's how we do it. All right. Any questions? So that is the average or the mean. Okay. All right. So let us look at something else. So the mean is the average. The median is the middle number. And to find the median, what we do is we collect all the numbers and we put them in order. So I'm going to write a series of numbers. All right, so I'm going to write a series of numbers. Let's say we have 96, we have 80, we have 91, we have 83, and 87, 88, and 90. All right. And we have 90. Okay. So this is our range of numbers. If we wanted to find the mean or the average, we would add all of these up and divide by 8. To find the median, we have to put them in order. This is a different color. We put them in order from lowest to highest. So we have 80, and we have 83, Then we have 87. We have 88. Then we have 90. We have 90. We have 91. And we have 96. Okay, so the median is just the middle one. All right. In this instance, we have 1, 2, 3, 4, 5, 6, 7. We have 8 of them, right? So the middle would be in here. We don't have a middle number. If we had an odd number, so if I had this instead, if I only had 190, one of the 90s, I should say. In that sense, 3 above, 3 below, this would be the median. So it's the middle number. When you have odd numbers, it's whatever one comes in the middle. If you have even numbers, we take the average of these two numbers, or the mean of those two numbers, to find the median. So if it's odd, we choose the middle. So if we have an odd number of numbers, we choose the middle. If we have an even number of numbers, we take the mean or the average of the middle two. So in this case would be 88 plus 90 divided by 2, okay? Which would give us 178 divided by 2, which would give us 89. And that makes sense, right? Because 89 is between 88 and 90. So the median is the middle. Sometimes the median and the mean are the same, sometimes they're not. So you have to pay attention when they're giving you these values. They'll say find the mean. You want to remember mean is average, median is middle. So the way to remember it is median has a D like middle. Okay? So the last one is mode. Mode is the one that appears most frequently. So in this instance, we have 80, 83, 87, 88, 90, 90, 91, and 96. Which one appears the most often? 90. So that would be the mode. And that's what you have to do for the statistics of the on the casing. Now, sometimes, anybody have any questions on those? All right. Okay. Now, sometimes what they may do on the case is they may give you a chart or a graph or something, and you just have to look at values. So let's look at that case. Okay, so sometimes they'll give you something like a pie chart, okay? And they'll divide it into percents. And we covered percents last time. So I'm just going to use this one here. Now, let's do this way. All right, so we're going to talk about time. All right, so we're going to look at as if we're dealing with time. Okay, so this is your sleeping time. Let's say that is, I don't know, your young people, 6 hours. And if we're talking about time, there are 24 hours in a day, okay? Let's say social media time, 10 hours. We'll put entertainment and social media. Okay, so that's 16. Let's say you've got, 2 hours of transportation that's going from one place to the other. So that's 18. And let's say you've got maybe, 2 hours of eating. Okay. Eating, so that gives us what? That's 10, that's 20. And then you have study time, which would be 4 hours. Okay. Now, sometimes they may give you something like this and ask you to calculate the percents. Okay, and then last time we talked about percents. So in this instance, there are 24 hours in a day. So to find the percents for sleep, it would be 6 divided by 24, which we would turn into a fraction. Transportation, 2 divided by 24. Study, 4 divided by 24. Eating, 2 divided by 24. And entertainment, social media, would be 10 divided by 24. And obviously we could reduce all of these. So this would be 1/4, because 6 divided by 6 is 1, 24 divided by 6 is 4. This would be 1/12, this would be 1/6, this would be 1/12, and this would be 5/12. And if you recall, to turn these into a percent, we would just multiply by 100 over 1 and then reduce. So we would do that. So they'll give you a problem that looks like this. And the thing with the pie charts, the size of the pie represents approximately how much value. So you would never end up with something like a pie chart where this is 10 and this is 4. Okay? Because that doesn't make sense, because 10 is larger than 4. So the area of the pie chart is roughly about the same proportion as the value to the whole. Okay? And that's what they're going to give you. If they give you percents, then you'll have to calculate some sort of value. So let's give an example of that. Anybody clear on this one? How to go from a value to a percent? It's just whatever value you have divided by the total. They may give you something like this. We'll use an example of a starving college student. Starving college student paycheck. Okay? So, probably about, let's do it this way. Probably about half of the paycheck is room and board. And that just means food and shelter. That's 50%. Okay. And then let's say about 20% is tuition and expenses. And let's just say another 20% is for transportation. And then their last 10% is for entertainment. Okay. So they may give you something along this line, and they say, you know, if Diana, if her weekly paycheck was $300, that means in a month, we say there are 4 weeks in a month, she makes $1,200. How much does she spend on tuition? And so it's 20% of $1,200. And then you would just, again, like we talked about with percents, turn this into a decimal. 0.2 times 1,200, and then you would be able to calculate what her expenses for tuition would be. That make sense? If they give you percents, they're going to give you some dollar value and ask you, well, how much of a person's total paycheck, or how much of something they do, how much of their pizza, or what have you. They will give you a percent, and you'll have a percent with a pie chart, and they'll give you a number, you'll have to calculate it. Or the other way, they'll give you a pie chart with numbers, and you have to calculate percents. Any questions? Questions? All right. Now, the other type of graph that they are prone to give you is they'll give you something that has this. This is the y-axis. You remember back to algebra, and this is the x-axis. And they're going to give you some value over here and then some value over here. So let's see, what do they do here? Nah, we don't want to talk about the Roadster. Let's talk about water usage in California, for instance. All right. So let's say in 2010, 2010, 2011, 2012, 2013, 2014. And they'll say that water, and they'll ask you what is the trend? Is it going down over time? Is it going up over time? So you have to look at what are called trends. And that's just how the graph looks. It could be going up, like in the same time period, gas prices could be going up like that. So what they're going to ask you for, they're going to ask you for trends. They're going to say, when did it go up the most? So you can have a graph that looks something like this. Water usage was going like this. Then it dropped here like this. And they'll say, what years did it go down the most? Well, it has the steepest decline between 2011 and 2012. So that's when it went down the most. For gas prices, it may be something along this line where it'll go up like this, and it'll go up like this. And they'll say, between what years did it increase the most? So the thing with the graphs and the charts is they're going to ask you for trends. They're going to ask you what happened over the time or over the distance. So you want to look at the shape of the graph, how fast it goes up, how fast it goes down, or whether it's flat. So that's kind of what they're going to do with trends. And that also falls under statistics. Something else they may give you, you have any questions on these? Something else they may give you is they may give you bar graphs as well. Okay, and a bar graph essentially is same type of thing. They give you an X and Y axis, but instead they give you these kind of things. And they can be that shape. They can be where they're going constantly up, or they can be going constantly down. Okay? And they'll ask you, I don't know, let's say this is noise level on your MP3 level. And let's say anything beyond this, you'll be deaf. And they may say, I don't know, let's say classical music. This is rock. This is country. And this is hip hop. They'll say, which types of music will make you go deaf? Oh, really? Rock and hip hop will make you go deaf. So they'll give you something along that line. They'll give you some sort of graph and they'll ask you for what happens over value. So it's not just looking at the values. They're going to ask you a question about the values. Okay? Or they may give you something like this, where the bar graph is sideways. They may give it to you this way as well. So don't be confused by that. And let's say something else that's interesting. Not gonna say that. Oh. Let's talk about, I don't know, how many times Kim Kardashian appears on TMZ. Let's say in 2014, 2013, 2012, 2011, and let's say 10, this is 14, this is 20, and this is 8. No, yeah, about 8, okay? And they may say, how many more times did she appear on the cover of TMZ in 2012 and in 2014? So in 2012 it was 20, 2014 it was 10, you subtract the 2 and you would get something like 10. And 215, 0. Okay. Watch, I'll post it online and Kanye West will do some sort of video. Don't you talk about my girlfriend. It'll go viral or something, I don't know. Sorry. Okay, now let's talk about probability. Okay, probability is real simple. We have the possible outcomes and the desired outcomes. So the desired outcomes divided by the possible outcomes, this is probability. Okay, so let's talk about what that means. Let's say you have a bag full of M&Ms, all right? And M&Ms, I don't know, they come in red, yellow, green, another color, blue, and brown. So let's say you have a bag full of M&Ms. They had the same number of each one of these. But you love the yellow M&Ms. Okay. So what is the probability of you sticking your hand in the bag and getting a yellow M&M? Well, the desired one over the total number of possibilities. 1, 2, 3, 4, 5. So I have a 1 out of 5 chance of getting a yellow M&M if I had the same number of M&Ms. Okay? So that's what probability is. Okay? And essentially that's all you have to remember for a probability. If you were to, I don't know, let's say you were to enter into some sort of competition or lottery or something like that, and they tell you there are 50 numbers, and if you pick the right number, you get, $100. So there's one right number out of 50 possibilities, so you have a 1 out of 50 chance. Okay? But you may say, hey, I'm going to spend an extra $1. I will get 2 numbers. Then you would have a 2 out of 50 chance, or 1 out of 25. Okay? Let's say you were taking a test. Oh, I don't know, like the Casey. And on the Casey, let's say that there are 5 possible answers. A, B, C, D, and E. And you have no idea which is the right one. You're like, I have never seen this question. I don't know what to do. So you say, I'm just going to guess. So you say, I'm going to guess any one of them. Well, there's one right answer and 5 possibilities. So you have a 1 out of 5 chance of getting it. But let's say, before you guess, you say, you know what? I know for sure that the answer is not B, and I know for sure that the answer is not E. So I'm not going to guess one of those. I'm only going to guess one of these. So now I have a 1 out of 3 chance. Like we covered last time with percents, if I want to turn this to a percent, I just multiply by 100 over 1, which will give me 100 over 5. 5 goes into 100. 2 times 10, 0, bring down the 0. 20, this is a 20% chance. Multiply by 100 over 1. That's going to give me 100 over 3. 3 goes into 100. 3 goes into 10 3 times. That's 9. Carry 1, bring down the 0. 33, well, 33 and a third. I have a higher probability of getting the right answer if I can eliminate 2, right? So rather than just closing my eyes and going, that one, if I get rid of these 2 and then randomly choose between the other one, I increase my chances of getting it right. Which is why when you're taking a test, if you don't know the answer, you want to eliminate the ones you know for sure are not right. And then you increase your chances. If I could get rid of another one, now I've got a 1 out of 2 chance, which is 50%. So I got a 50-50 chance of getting it right. That make sense? So probability is the desired outcomes by the possible outcomes. On a test, if I can decrease the possible outcomes, I increase my probability of getting it right. That make sense? All right. That is probability. Okay, so there's one more instance of probability that I want to cover. That's if there are more than one choice. Okay? So, let's say I have oh, I don't know. Let's say I have red, green, orange, brown, and silver. Okay. It's not going. Let's go with black. And we'll add white. So, in a parking garage, there are different color cars. All right, there's a black car, green car, orange car, brown car, silver car, or white car. So the probability of me getting run over by any of these cars is 1 out of 6, right? But let's say all the cars are like Toyotas and Hondas. All right? So if I have equal number of Toyotas and Hondas, I got a 50-50 chance of getting hit by a Toyota, right? But let's say I've got equal numbers of these, all right? So the probability of me getting hit by a black Toyota is 1 out of 6 times the probability here, 1 out of 2. So I have a 1 out of 12 probability of getting hit by a black Toyota, assuming that you have equal numbers here and equal numbers here. Equal number of black Toyotas, equal number of green Toyotas, equal number, so forth. So when you have two different probabilities, you calculate them separately and then you multiply them together. So you'll have some of those. So for instance, they may say, if you, okay, that's a good one. These questions are old, like Bob Newhart. That's really funny. So let's say I have I've got a bag full of money. I've got 4 quarters, 2 dimes, and 1 nickel. Okay. So the probability of me getting a quarter out of this bunch would be what? What's my total possible outcomes? I have a total of 7 coins, right? Right? 4 of them are quarters, so the chance of me getting a quarter, 4 out of 7. Okay? So let's say I did get a quarter. All right? So now I have 3 quarters left, 2 dimes, and 1 nickel. Okay? What's the chance of me getting another quarter? Right? Well, now I have 3 out of 6 because I already took 1 quarter out, right? So if I start off with this probability, I have 4 chances of getting a quarter out of 7 coins. But once I take that quarter out, I only have 6 coins, and I've got 3 quarters now. Does that make sense? Okay. So those are our probabilities. Any questions on those? Nope. All right. So there are 12 different questions between statistics and probability. The probability is probably the hardest one. Things about probability, your probability can never be greater than 1 because you don't have more outcomes and possibilities. Okay.